So hello everyone, in this video we are going to see a data structure which is known as a linked list. Okay, so we're gonna discuss what is a linked list and why linked list is necessary, and we are also going to see its implementation, okay, in C language, how we can implement our linked list data structure, implementation of linked list. Okay, so So what is our first goal? What is linked list? So in simple terms, if I'm gonna tell about linked list, so linked list is a linear data structure. Okay. So why we need it? Before that we have a data structure called array. But in array we have some limitation, like we can't grow the size of our array at runtime. But in linked list we can easily able to grow the size of our linked list at runtime. Why we can do it? Because linked list is dynamic in nature, but array is static in nature. What does that mean? For declaring an array, how we will declare an array? We will write something as, if we want to create an integer array, so we will going to write int array and the size of our array. So we are explicitly mentioning about the size, that we are going to create an array having size 12 elements. We will store 12 integer in our array. Okay, so we also have concept of dynamic array, but in this video we are going to compare about linked list and the normal array, that is static array. Okay, so linked list is dynamic in nature. So just because of this dynamic, what are the things which we can achieve using linked list? So linked list is dynamic. Okay, we can grow and shrink it at runtime based on our requirement. Like if we want to insert a node, we can simply call a function. So whatever operation we are expecting from our linked list, we can easily do it on our runtime. But also there is no memory wastage. Like we have created an array having size 100, but in our programming, what I say, in our problem solving or any requirement comes, we only use the size of our array as 50. So the 50 byte, what I say, 50 or integer will consume 4 bytes. So 50 into 4 will means 200 byte will be, what I say, wastage. So linked list, whenever we are using linked list as a data structure, we have a flexibility of our memory. We have the memory management. We can also, what I say, save our memory. So memory wastage is also neglected in our linked list data structure. Okay, so as it is a linear data structure, the operation which we perform of our linked list is very easier. Like whatever operation we are performing, like insertion, deletion, searching, likewise, so we can easily perform all those operations. Okay, and also linked list can be, why we can learn about linked list. So we also have type of linked list. Okay, so types of linked list. Okay, so linked list is of 4 types. Like we have singly linked list, which we are going to learn in this video, that is singly linked list. Okay, another one is the doubly linked list. Okay, doubly linked list. Third one is our circular linked list. Okay, circular linked list. And fourth one is our doubly circular linked list. Okay, so these 4 type of our linked list is present. Okay, so these are the bifurcation which we have created in our linked list. Okay, so also Linked list can be also used for implemented binary search as well as binary search tree or stack or queue. We can also implement stack as well as queue using what? Using array. But if we want to make it efficient, okay, so we can also use linked list. So now what are the things which we have covered right now? Like what is a linked list? Why linked list is necessary? Implementation of linked list is, I will going to write the code for that, and type of linked list. So now we will going to see the operation which we perform on our linked list. Okay, and so first of all we will include our header file as has include stdio.h. This header file is mostly used for the standard input output in C language. Okay, and also we will use memory allocation. So for that we will use the library that is stdlib.h. Okay, now using structure we will define our own custom data type, that is struct node. We are going to create our own data type known as node. Okay, so in this we have two parts. First one is data and another one is a pointer which is pointing to a node, and this type of pointer is known as self-referential structure. What does that mean? It is, this pointer is going to point that memory location which belongs to it. Like whenever we want to store address of an integer variable, we will use an integer pointer. But whenever we are going to, like, what, why this next pointer is used? Next pointer is mostly used for linking two nodes. Okay, basically linked list is a, what I say, it's a data structure which is also linked together using a pointer. So this is a pointer through which we will link our node. Now we will going to write different operation which we want to implement on our linked list data structure. So for that we will create a pointer variable that is start. So this is a null pointer. Okay, it won't point to any node till now. So using this start pointer we will traverse our linked list, or we can perform different operation on our linked list. So this is the start pointer which is pointing to the first node of our linked list. Now we want to write our custom function like insertion, searching as well as deletion. So insertion can be performed in three ways. Like if you want to insert a node or insert a element in the beginning, so for that we have a function called as insert at beginning, which I am going to code it. Okay, like this we also have a function called as insertion at middle, whenever we want to insert a node in our middle position. And the last operation for the insertion is insertion at end, whenever we want to insert a node at end. So this is the point where our insertion is completed. Now also we have something called as searching. Let's say we have a linked list, and as we have performed our operation like linear search in our array, like we want to search an element if that element is present in our linked list or not. Okay, so for that we will use a function that is searching. And we also have a function of traversing, like we want to visit every node at least once. So for that we will use a function called traversing. Traversing is also used for checking that if our insertion or deletion operation is performing, whatever we have coded is working fine or not. And also we have called deletion, like as we can tell, like this is no memory wastage is present in our linked list. So how we can, what I say, efficiently use our linked list? So let's say we have a three operation, like if we want to delete a node from beginning or from middle or from end. So all this function we are going to see in this video. So now I'm going to execute it. So I will call a function insert at start. Okay, or beginning, we can write anything. So whenever, so what are the formal arguments which we need in this function? That is nothing but a data which we want to store in our node, or also a pointer, that is nothing but star star start. Okay, so this is nothing but a, we are passing a address of a pointer variable. Like we have created a pointer in our main function, and the, what I say, the variable name is start, so we are passing the address of this start pointer. So start is also a pointer, so for storing the address of a pointer we need two pointers, that is star star. Like now we will create a node. Okay, so struct node asterisk a assign malloc. Okay, malloc is a predefined function which is used for allocating memory at runtime. Malloc size of struct node. So we have created a memory block, and that memory block is going to pointed by a variable which is known as a. So a is a pointer variable which is pointing to a node, and in that node we have two member variable like data and one a pointer which is pointing to another node. So we are going to insert this node at start. Okay, so we also need to typecast it. Okay, because malloc return a void pointer. Okay, so we need to typecast it struct node asterisk. Okay, so now we need to insert the value present in our node data structure. Okay, node, not a data structure. We want to insert some data like a arrow data, assign data whatever is coming in our function. Okay, a arrow next, these are the member variable. Okay, so a arrow next will be assigned with asterisk of start. Okay, now asterisk of start will point to a variable a. So what this code, this 4 line of code represent, now we want to insert a node. For inserting a node we want to allocate it at runtime. So using malloc function we have done that. Okay, so and in the next step, in that node we have assigned a value. Okay, so for that we have used a arrow data, assign data. Okay, in the next pointer, whatever the value of start, if it is pointing to null, so it will a arrow next, the value which we are going to initialize in our pointer, next pointer, that is equals to a streak of start. So in the beginning we don't have any node, so the start will point to null, so this will point to null as we don't have any node in our, when we are going to run this code. So a arrow next assign asterisk of start, and this is the first node, so start pointer is going to point this node, so asterisk of start assign a. So the insertion at start is done. Now we will see insertion at last. Okay, so same, we will going to receive the same argument like data as well as a pointer which is pointing to a first node of our linked list. Okay, we also going to write this code same. Okay, so we will copy it. Now if now we will going to check the condition, because we are going to insert a node at end. So it might be possible whenever we are calling this function we don't have any node, so in that case what will the value of our start? So if asterisk of start is equals to null, what does that mean? We don't have any node, so this node is going to insert as a starting node or the first node. So asterisk a arrow next assign null. Okay, and asterisk of a, not asterisk of start assign a. Okay, else, when this else part will going to execute when we have at least one node. So we have one node, or we can have node like 10, 20, 100 based on our implementation. Okay, we don't know what is the size of our linked list, so for that we will create a pointer variable for traversing till last node. So we have created a pointer struct node asterisk C. Okay, and the initial value of our this pointer is string of start. Now we will use a loop while C arrow next not equal to null. Why we are going to write this condition while C arrow next not equal to null? Because we know that the last node or the first node of our linked list have two member variable like data, and we have a pointer as next. So the last node of our linked list or the beginning node of our linked list have two member variable. So in the next member variable we have nothing, we have a value called null. So we are going to check while C arrow next not equal to null. So we will traverse or we will write a loop till we don't reach at the last node. So in this loop we will going to execute C assign C arrow next. Okay, so when this condition is false, which means we have reached to the last node, so only we need to do C arrow next assign A, that's it. Okay, now insertion operation has been completed. Now we will going to call this. So I am not going to make it as a using switch case. Okay, I am simply testing it. 10 address of start. Okay, and also a function called as insert at last. Will this working or not? I am going to check it. Okay, address of start. We are not going to create it as menu driven. Okay, for making our program as menu driven we will use switch case. Now we also need to traverse our list, or we can also call it as view list. Okay, so void traverse. So the return type of this traverse function is void. It is not going to return anything. Okay, it will only traverse each and every node at least once. So this we have send a pointer, so we have stored it in a variable that is A. So in the starting we will check if A equals to null, means we have two cases. We can conclude it like we don't, in the starting we don't have any node, so for that we need to pass a message like if age equals to null, printf what, no, linked list is empty, we don't have any node, linked list is empty. Okay, and after that we will use a return keyword. Else means we have one node, so for that we will traverse while a not equal to null, printf %d a arrow data, and the value of a will be updated by a arrow next. Okay, now we will run our code and see is there any bug. Okay, so insert at start, 10 will be inserted at start, and we have insert at last, so 100 will be insert at last. Now again we are going to call insert at start having data as 15, address of start. Let's see if it work or not. Again we will call a function insert at start by passing 90, address of start. Now we will run it. So 90 will be first node. So as we can see, 90 is inserted at first, after that we have 15, now we have 10, and in the last we have 100. Now if we need to call insert at last, okay, so in the last we have passing our data as 78, so this 78 will be inserted at last. So as we can see, after 100 we have 78, so the insertion operation is working fine on our linked list. So whatever data structure we have created, this is known as a custom data structure. We are creating it. Okay, we are making it a custom data type, data structure. Okay, we also have STL in C++ where all this coding is done. We only need to use it. Okay, but for understanding how the data structure work, we need to implement our own data structure at least once. So we will go to learn how the coding is working and how our logic is also working. Now we will see another operation that is called as deletion. Deletion from start. Okay, start, we will pass address of start, that's it. Now what we can do, so deletion at start or insertion at start will be done in constant time. Okay, only deletion as well as insertion at end will take big O of n. Why? Because we need to traverse each and every node because we need to traverse since last node. Okay, so void deletion from start struct node asterisk asterisk a struct node asterisk b assign what asterisk of a. So deletion from start, we are deleting a node from start. So we have created a pointer b which is pointing to first node of our linked list. Okay, now we can write asterisk of a, we can simply write asterisk of a assign what b arrow next, and after that we will simply free this b pointer. Okay, so as we can traverse the first node. Okay, so after the insertion we will call a traverse function, traverse start. After that we will use a printf function for changing the line. Okay, so as we can see 15 by running it, our first node is 90, but after calling this function, that is nothing but deletion from start, this 90 will be deleted from our new list. Okay, now we will see deletion from end. Okay, deletion from end. Here also we will pass start. Okay, why? I am going to explain it. Void insert at not insert deletion from end. Okay, struct node asterisk asterisk a. Okay, so if we are checking, if we have only one node, so we can simply free it. So if asterisk a is equals to null, then what we are going to do, we will free asterisk of a, and asterisk of a will be now pointing to null because we don't have any node. Else we will traverse. So for traversing we will need two pointer variable. Okay, struct node asterisk b assign asterisk a asterisk c assign null. Now we will going to run a loop while b arrow next not equal to null. B c assign b assign b arrow next. Why we are going to do this? Because c will point to last node, second last node, and b will point to last node. So after completing this loop we will only write c arrow next should assign null. Okay, c arrow next will be assigned with null, and we simply free what b, that's it. Okay, now after this deletion we are going to traverse it. Let's see what will be our output. So as we can see, first we have this linked list. Now we have delete from start, we have deleted a node from start, so 90 will be deleted. After that we have deleted a node from end which is 78. So as we can see 90 and 78 is deleted. Now again we are going to delete it from end. Delete from end address of start, so 100 will be deleted from our linked list. So as we can see 100 is deleted from our original linked list. So in this video, so I am binding up this video. So what are the operation we have seen in our this video, like why we need linked list, okay, what are the advantage of linked list, and why, and which data structure is can implement using linked list. Okay, after that we will see the implementation of our linked list. We have written 4 functions. First one of them is insertion at starting or ending, and one function is for traversing, and the two function is for deletion from start and deletion from end. If we need to make this program as menu driven, we can also use switch case for it. Okay, so in the next video we will see the two different operation like insertion at middle or deletion at middle, and we need to implement our linked list using menu driven program. So that's it from this video. I hope you like the video. Make sure to comment it, and we will see in the next video. Till then, bye, thank you, goodbye.